Okay, in this video, I'm going to show you questions and answers related to application of partial differentiation. In particular, to find the maximum or minimum of a critical point. So here we need to do what we call the M test to determine maximum or minimum. So the formula for M is given by the function f(x(x) times function f(y(y) minus f(xy) to the power of 2. Okay? So here we need to find the value of M, and M must be greater than 0 and f(x(x) must be less than 0 so that the function will become maximum. And when M is greater than 0 and the function f(x(x) is also greater than 0, then the function is said to be minimum. Okay? But if M is less than 0 and the function fx is said to have a saddle point, which is neither a maximum nor a minimum. Okay? And when M is equal to 0, then the test does not provide any conclusion at all. Okay? So we need to look out for the value of M to be greater than 0 first, and then followed by the value of f(x(x). If it is less than 0, then it is maximum. If f(x(x) is greater than 0, then the function is minimum. Okay? Let's look at a sample question here. So given that the function f(xy) is equal to y minus y squared minus 3x minus 6x squared. We are asked to find the critical point of this function, and then part 2, determine whether this critical point is maximum or minimum. Okay, so let's start with the function. So the first step is to find the differentiation of this function compared with x. So look at only the terms with x. Here there's no x, here there's no x2, and then here we have x. So differentiate negative 3x, the answer is negative 3. And then differentiate negative 6x squared, the answer is negative 12x. So this answer we will equate with 0 in order to find the value of x for the critical point. So shift negative 12x to the right, we have positive 12x. So if negative 3 equals to 12x, therefore x is equals to negative 3 over 12 or negative 1 over 4. Alright, next we find the differentiation of the function f compared with y. The answer is 1 minus 2y. Again equals to 0. Therefore we have 1, shift the negative 2y to the right. We have 1 equals to 2y. Alright, so from here y is equals to 1 over 2. Okay, so the critical point for this function will be negative 1 over 4 and half. Alright, so let's look at part 2. In part 2, we need to determine whether it is a maximum or minimum. So we need to carry out the M test. So start off with the function f(x), alright, which we have found as negative 3 minus 12x. So we will differentiate the second time, compare with x. So look at negative 12x, differentiate, we will get negative 12. And then followed by fxy. So differentiate fx compared to y. But since there's no y here, so the answer is 0. Alright? Then we find fy, which we have found earlier in part 1. Fy is equals to 1 minus 2y. So we need to find what is fyy. So differentiate this function compared to y. So negative 2y will give us negative 2. Alright, so from here substitute into the formula M equals to f(x(x) times fyy minus fxy squared. So we will get f(x(x) is negative 12, fyy is negative 2 minus fxy equals to 0. Alright, so from here negative 12 times negative 2, the answer is 24, and then minus 0, so answer is 24. 24 is greater than 0. Alright, the next step is we look at the sign of fxx. Since fxx is equals to negative 12, which is less than 0, that means this function or this critical point is a maximum. Okay.